In this video, we're going to look at solving radical and rational equations. Radical equations will involve a square root or a cube root, sometimes a higher root, but we're going to stick with square root and cube root. In our first example, let's look at the square root of x plus 8 minus 2 equals 0. If your radical term is not isolated, that's the first thing you go for. In this problem, we need to add 2 to both sides. Once you've isolated the radical term, then to remove a square root radical, you square both sides. A square root and a square undo each other. So that's going to give us x plus 8. A couple of 2's multiplied make 4. Subtract 8. Now with square root equations, you will need to check your answer. This is a candidate. If we substitute that in for x, into the original problem, I'm going to use a question mark because I don't know if it's going to work or not. I think it will. Negative 4 plus 8. That gives us 2 minus 2, which in fact does equal 0. Now since that's true, we get to keep this as our answer. Let's solve four plus cube root. It'll have an index of a 3, 4x minus 5 equals 0. Like we did in the last example, we need to isolate the radical term, subtracting 4 from both sides. Zero minus 4 is negative 4. This time, in order to remove the radical, we're going to cube both sides. The cube root and the power of 3 are going to undo each other, in other words, cancel each other. And so that gives us 4x minus 5. 3 negative 4's multiplied together totaled negative 64. Add 5. Negative 64 plus 5. And then divide by 4. If you wanted to check this in the original problem, substitute negative 59 over 4 in place of x. That would go right here. Excuse me. 4 times negative 59 fourths would be negative 59. Minus 5 is negative 64. Cube root of negative 64 is negative 4, which does check out to 0. And what that means is we get to keep this as our solution. Let's solve the square root. I always forget to change my ink back. Square root of x plus 7 equals x plus 1. The radical term is already isolated, so we can immediately step in and square both sides to remove it. Your square root and your square will cancel one another. So that gives us x plus 7 is equal to, now you got to be very careful here. X plus 1 quantity squared, that means there's 2 of them. FOIL method and combining the outer and inner parts, you're going to get x squared plus 1x plus 1x plus 1. First, outer, inner, and last. We do need to collect all terms on one side because this is called a quadratic equation when you have a dominant power of 2. So far, all we've solved are linear, but this one, we have an x squared term show up, so we're going to have to use a different method to solve it. Okay, so with a quadratic, let's zero out one side entirely. 2x minus 1x, 1 minus 7, can you think of two numbers? They have to add up to positive 1, because that's your middle coefficient, but they also have to multiply out to negative 6. That's the constant on the end. So we need two numbers that will add up to 1 and times out to negative 6. The first set of parentheses equals 0 if x is negative 3. The second set of parentheses is equal to 0 if x equals 2. In the original problem, negative 3 plus 7 I'm going to use a question mark because I don't know if this is going to be equal or not. Is that equal to negative 3 plus 1? Negative 3 plus 7 is 4. Square root of 4 is 2, which does not equal negative 2. So that answer is out. Let's try 2. Square root of 2 plus 7. Again, I'm going to use a question mark because I don't know. Equals 2 plus 1. So that's square root of 9 equals 3. Hey, those equal. If the number you're checking works out, then that's your answer. Sometimes you get two answers, but only one of them checks in the original problem. In our last example for this video, let's kind of go back and look at the equations that involve fractions. In linear equations part 2, we solved a few of them that were fractions in the beginning. Let's look at 4 over x minus 5/3 is equal to x over 6. Okay, so this is called a rational equation. We're going to look at more later on in the class. But for now, it's just mainly practicing multiplying through by least common denominator. The numerical values 3 and 6, let's think of a number that they will both divide into evenly. 6 is a candidate. You can use a 6. You could use a 12, an 18. As long as the number you pick is divisible by all of your numerical denominators, you can use it. I'm just going to use a 6. There's also an x for a denominator, so I'm going to use 6x and multiply all the way through. Okay, so we have 4 over x minus, this one will be a 5/3, and x over 6. In the first group, your x's cancel, leaving a 24, 6 times 4. In the second group, 3 goes into 6 twice. 2 times x times 5, that's 10x. And then over here on the far right side, your 6's cancel completely, leaving x times x, which is x squared. Now this introduces an x squared term, and like the last example, that's called a quadratic equation. If we move all terms to one side, I'm going to take off 24 and add a 10x. So I'm going to do plus 10x and a minus 24. What that does is that zeroes out one side. So I've got on the right side of the equation x squared plus 10x minus 24. Can you think of two numbers that add up to 10 but multiply out to negative 24? It's tempting to try to use 6 and 4, but you actually need to use a 12 and a negative 2. The first set of parentheses equals 0 when x is negative 12. The second set of parentheses equals 0 when x equals 2. You're more than welcome to check these in the original problem. In fact, I recommend it. If you're not 100% that your solution technique is accurate, you can always check these in the original problem. If they work, great. If they don't, mark them out. It turns out both of them do work in the original problem. So for this example, there are two solutions.